Imagine floating in the middle of a cosmic desert. Not just empty space, but a region so vast and underpopulated, it stretches across 2 billion light-years. This isn't science fiction. It's real, and we're in it. It's called the KBC Void, named after the astronomers who discovered it, Keenan, Barger, and Cowie. Also known as the local hole, this is one of the largest known cosmic voids ever mapped. And here's the twist. We're sitting dangerously close to its center. Now, if this sounds unusual, that's because it is. The universe is supposed to be pretty uniform on large scales, a smooth blend of galaxies, stars, and dark matter. But this is like finding a vast empty crater in what should have been a cosmic city. And it gets weirder. The size of this void isn't just large. It's 7 times bigger than what scientists thought was even possible under our current models of the universe. A place this empty, this vast, isn't just surprising, it's a problem. Because if this void is real, and all evidence says it is, it forces us to rethink everything we thought we understood about how the universe is built. So how did scientists even realize we were inside a massive cosmic hole? It all began with a closer look at how galaxies are spread out in our corner of the universe. Astronomers use something called galaxy redshift surveys, a way to map how light stretches as galaxies move farther away. Think of it like a cosmic radar, showing not just where galaxies are, but how fast they're moving. Using this data, they built a 3-dimensional map of nearby galaxies. And what they saw was shocking, a huge spherical region around us with far fewer galaxies than expected. Not a small pocket of emptiness, but a yawning gap stretching billions of light-years in every direction. At first, many experts dismissed it. The idea of such a large void seemed too extreme, even impossible, under the standard model of cosmology. But the evidence kept piling up. New telescopes, new surveys, and each time, they confirmed the same thing. There's a massive, empty region surrounding us, and we're sitting near its center. What started as a strange observation became undeniable, and with it came a question no one was ready for. If the universe really works the way we think it does, how can this void even exist? The discovery of the KBC Void didn't just surprise scientists. It threatened to break the foundation of modern cosmology. First, there's the cosmological principle. It's a basic assumption. On a large enough scale, the universe should look the same in every direction. Matter should be evenly spread out, no giant gaps, no massive clumps. But the KBC Void isn't just a small dip in density. It's a colossal underdensity, a region with dramatically fewer galaxies than the rest of the universe. If we're really in the center of such a void, then that principle? It might not hold. Then there's the second problem, simulations. Cosmologists use powerful computer models to simulate how the universe evolved from the Big Bang to now. One of the biggest is the MXXL simulation, which runs using the standard lambda cold dark matter model, the lambda CDM model. And here's the issue. In thousands of simulated universes, none formed a void as large as the one we're in. The math just doesn't support it. According to these simulations, the gravitational forces in our universe shouldn't be strong enough, or chaotic enough, to carve out such a deep, wide hole. In short, the KBC Void shouldn't exist. But it does. And that means either our models are incomplete, or there's something about the universe we've completely misunderstood. Now here's where things get really strange, and possibly revolutionary. You may have heard of the Hubble Tension. It's one of the biggest unsolved problems in modern cosmology. In simple terms, scientists can't agree on how fast the universe is expanding. And that's a big deal, because the expansion rate, known as the Hubble constant, directly affects our estimate of the universe's age and future. Here's the conflict. When astronomers look at nearby galaxies, they get a higher number, around 73 kilometers per second per megaparsec. But when they measure the expansion from the early universe, using the cosmic microwave background, they get a lower number, closer to 67. That difference might sound small, but in cosmology, it's massive. It's not just a measuring error. It suggests that something fundamental is missing in our understanding. And here's where the KBC Void steps in. Inside this gigantic cosmic hole, there's less matter than average. Fewer galaxies, fewer stars, less gravitational pull. That matters because gravity affects how fast things move. And if we're inside a low-density region, then the space around us could appear to expand faster than it actually is. Meanwhile, the denser regions outside the void pull matter outward more strongly, exaggerating the local expansion even further. From our perspective, it looks like everything is racing away at high speed. But it's an illusion. This could explain why local measurements of the Hubble constant are higher, and why they clash with data from the early universe. In other words, we may not need new physics to explain the Hubble tension. We might just be in the wrong neighborhood. The discovery of the KBC Void is more than just a strange footnote in astronomy. It's a cosmic curveball that challenges our models, our assumptions, and even our place in the universe. It could explain why the universe appears to be expanding faster than it should. It might help resolve the baffling Hubble tension. And perhaps, most intriguingly, it offers a real-world explanation for why the cosmos remains silent, despite the overwhelming odds that we're not alone. Maybe the answer to the Fermi Paradox isn't out there in the stars. Maybe it's right here, in the lonely, quiet patch of space we call home. And if that's true, then we're not just isolated. We're cosmically quarantined, not by design, but by geography. One thing is clear. The more we learn about the universe, the more it reminds us. We might not be the center of it, but we are at the center of something strange. If this left you with more questions than answers, good, because the universe is full of them. Hit subscribe so you're here for the next mystery we uncover.